Hello friends, welcome to my channel. Let's have a look at problem 86, partition list. So this is a daily challenge problem. So here in this video, we're going to share first a brute force solution, and then we transform the brute force solution in a better format. So this problem is the following. Given the head of linked list and a value x, partition it such that all nodes less than x comes before nodes greater than or equal to x. So we should preserve the original relative order of the nodes in each of the two partitions. So here are examples. So let's have a look at the constraints. So the first constraint says that maybe the linked list is empty because the number node can be 0. And the length of the linked list is bounded above by 200. So the value for a node is between negative 100 and positive 100. And the value x is between negative 200 and positive 200. So with that said, let's first look at a brute force solution. So this brute force solution will help us build intuition. So what we are going to do is that we want to traverse this linked list and then put the larger value and smaller value into two separate lists, and then we join them by making a number of list node objects. So with that said, let's do this, carry out this procedure. So first I'm going to introduce a smaller, let's see, larger. So these are two lists which are to hold the node values. So then we are going to traverse this linked list. So this is very standard. So while head, then we're going to check if head value is less than x or greater than or equal to x. So if it's less than x, we're going to add this value to the smaller list. So append, so head value. So let's do something like this. So value equals head value, and if value less than x, then we're going to add this value, and otherwise we're going to add it to the larger list. So then we're going to reset the state of head by head next. So that's it for this traversal. So let me make some remark. So here is a linear traversal. So this is very standard. So next we join the corresponding nodes. For that purpose, let's first make a dummy node, so for convenience. So list node as specified here. So it's list node, and we're going to use a value that is, so let me use negative 101 because it's smaller than negative 100. And then we're going to traverse the smaller and large list. So then we're going to do things like for x in smaller plus this larger. So then we're going to make a node. Let's see, temp equals list node. So the value will be the x, and then we're going to set the dummy next to temp, and then let me do things like this, maybe it's better. Current equals dummy, and then we're going to set current next equals this temp, and current equals temp. So then that's it. Then we just need to return the dummy next. So notice that we do this because the head can be representing a empty list. So let's test a special case. Yeah, it passes this special case, and then let's check a generic case. Yeah, it also passes the generic case. And now let's do another format. So this format actually just translates this brute force solution, but maybe more suited to the problem or more satisfactory. Let's call this one solution V1. And then, so this way, the brute force solution will work at the value level. So work at value level. So now let's do a solution so which will work at node level. So with the above solution, I guess the second solution is quite straightforward. I'm going to specify two nodes, so small dummy. So let's call it list node. So again, I'm going to use a value -101 in view of this constraint, and then I'm also going to set a large. So let's see, large dummy. So I'm going to use again value -101. Then we can actually do the iteration, same parallel to the above solution. So while head, then I'm going to check the value. So if head value is less than x, then we're going to connect this head node to a small, right? So we're going to make small next equals head, and then we move forward small to be small next. In other words, the current height. And otherwise, we're going to make large next equals this height. In other words, we connect the current height with the larger. And then what we're going to do is that we set large equals large next. And then after this conditions check, we're going to reset the height to be the next pointer. So with that said, actually we finished the while loop parallel to the brute force solution. And then what we are going to do is that we want to set the current state of small to be the large dummy next, right? So first I'm going to do something like this. If large, so the current state is not now, so we're going to set large next to be now. So this if actually plays a role. So this prevent possible cycles. So once this is done, see, we can make a connection, right? So if small, then what we're going to do is that we connect the end of the smaller linked list with the one has large values, that is large dummy next. So once this is done, so we're going to return dummy next. So the use of dummy node is a standard practice for problems involving linked list. So this is the second solution. So now let's do a special case check. So dummy is not defined. Let's see. I need to use dummy small. Dummy small is not a small dummy. Alright, so let's check again. Yeah, it passes the special case. Now let's do a generic case check. Yeah, it passes the generic case. So I guess that's it for this problem. So basically we present two formats of solutions. The first one is very brute force, but it serves to understand the logic of the problem. And then we translate the brute force solution to a solution that will work at node level. So in between, actually we used the dummy node for convenience. So this is a common practice for problems involving linked list. So that's it for this video. Thank you very much.